Welcome back everybody. Today we will discuss a statics problem related to beam reaction forces. So we need to evaluate the reaction force at support B for the below shown simply supported beam. Okay, so we have a trapezoidal load, and in case we have a trapezoidal load, we will split the load into two loads. The first load will be a rectangle load. So this is 3 kip on both sides, and a triangular load. This is the other load. It starts from 0 and it ends up with 8 minus 3, which is 5 kips. Okay, now we need to evaluate the resultant force for each separate distributed load. For the rectangle 1, if we have a rectangle load, W applied on a certain length L, so the resultant is W multiplied by L, and the distance from both sides is L over 2. So the resultant for the rectangle load is going to act in here. It will be 3 multiplied by 12. This is 36. And the distance is 6 foot in here and 6 foot in here. Now, for the triangular load, if we have a triangle load, we have a high part and we have a low part. So the resultant force is the area of that triangle, which is W multiplied by L divided by 2, and the location of that resultant load is 1/3 the length from the high side and 2/3 the length from the low side. Okay, so it will act almost here. So 5 multiplied by 12 divided by 2, this will give us 30 kip, and the distance from the high side is 1/3 12 foot, which is 4 foot, and from the low side it's gonna be 2/3 the 12, which is 8. Okay, if we need to evaluate the reaction force at B, we need to take the moment at A. Okay, so we know that the summation of moment at point A should equal to 0. So we have 30 kip multiplied by 4 foot. This is coming in the negative direction. And we have 36 multiplied by 6, also in the negative direction. Plus the reaction at B multiplied by the distance, which is 12, should equal to 0. That means 12 RP equals 30 multiplied by 4 plus 36 multiplied by 6. Divide both by 12. and the reaction at B would equal to 28. Okay, and that's B.